Okay, so this next part is the restrictions on rationals. So restriction, this is what I'm talking about. You are not allowed to divide by 0. So that's what we're talking about as a restriction. You are not allowed to divide by 0. Okay, so I'm going to look at just the bottom, the denominator, the divider. So I'm worried about what x value. I don't want x to be the number what? 3. Because if it was, the bottom would say 3 subtract 3, which is 0, and I don't want that. Okay, I don't want this x to be 0. If x was 0, the bottom would be 0. I don't want x to be, this is a fraction answer, same as your last unit. What did you say?
1/2.
Positive 1/2. Okay, it's the same as when you were factoring, same thing you're doing. So here, what fraction is it here? I don't want it to be a -4/5. Okay, this next one, I need you to actually factor this. So can you recognize it? You should get faster and faster. Simple trinomial, what multiplies and adds? Simple trinomial, what multiplies and adds? Okay, so once you have it factored, you don't want x to equal 8 or -5. And the last one, can you GCF the bottom? What would you pull out of this unit and this unit? 8 out. So this would be x, this would be a -2. I don't want x to be I don't want it to be a 2 now. Okay, so same as factoring. We haven't done anything different right now, really. Okay, reducing rationals. Okay, we are going to factor. Okay, so I need you to factor the top. I need you to use simple trinomial methods. Factor the top. So you should get what multiplying to 6 that adds to 5 as well? A +2 and a +3. This one's always tricky because 6 and 1 also make 5, but then one of them would have had to be negative. Okay, do you recognize the style? Are you recognizing styles? What is the bottom? Difference of squares. So attach your strategy with difference of squares, plus minus, and that would be 3. Okay, once everything is factored, I'm going to cancel anything that is the same on the top and bottom. So x plus 3 divided by an x plus 3 can go away. And that's my answer.
What thing?
I sounded like someone.
I thought it was just the wind.
Oh, you can't really video.
Okay, factor.
We learned this yesterday.
Factor.
Huh? Oh, we have a drug test?
Okay. So what do you want to do with this top? What style? What style is this top one? Complex trinomial? So my flow number is 8. Therefore, I know I'm using a 1 and an 8 to get a 9. 1 times 8 to get 8 and add to 9. This is 1x times 2x. There's only one option. This has 1, 4, or 2, 2. I need to make that 8 and the 1. 8 and a 1. So complex. What is the bottom? You're going to do something to it. What is the style in a name? Do you remember it? Negative out, because I don't like those negative x's. I don't like the negative letters. So negative 1 comes out, making a positive x and a positive 4. Now, x plus 4 can go away.
Yeah. I kind of like these are clean too.
Okay, one more. Okay, last one. What am I going to do to the top? Style. Should be fast at your styles. GCF. Recognizing, recognizing, recognizing. GCF. So what am I going to take out of each? 2m. So 2m times m. 2m times 1. Okay, what do you want to take out of the bottom? It's also a GCF, right? Did you recognize that?
Yep.
GCF, an M. So an M comes out of all of the terms. Okay, we're going to go further here. This is now a simple trinomial, so I have to factor it twice. We have the m, and then what? M and m multiplies to 2, adds to 3. Okay, so I'm done factoring. I did my GCF and trinomial. So what cancels? An m plus 1, top bottom, and this multiplier m, and that's it. Okay, here's a big thing to think about. Some of you might have said, well, why can't I cancel those 2's? Was anybody thinking that in their head?
Yes.
Why can't you? Because they are adders. You cannot cancel adders. You can only cancel things when they're connected with multiplying. So let me make you think about some digits. So if I made you think about some digits here. Okay, I know that this is 9/5. Okay? If you were thinking you could have canceled those 2's, here's what you would have been doing. Canceling that, which equals 4. Does that make sense? No. You cannot cancel adders. You can't cancel things that are connected with adding. If I did this, which is 20/5, then can I cancel the 5's? Yes. Okay, do you see the difference? This is the whole unit. If you're getting mixed up with this, you're going to get everything wrong. You cannot cancel adders like that. You can only cancel things that are multiplied. So when we set up our factors, when we have factors like that, there is multiplying between them. And that's why we can cancel factor sets. Sinking in? Does that make sense?